Bismillahirrahmanirrahim. Assalamu alaikum, students. Hopefully, every one of you will be good. Okay, today we are going to try another format. I'm going to record the lesson and then I'm going to share the link with you, a YouTube link with you, so that you can look upon the lecture and then you can learn from here. And then you have to do some questions in the middle of the lecture and at the end as well. So let's start the lesson. As you know that we are going through the chapter of waves. Okay, in waves, our today's topics will be first topic will be intensity or wave intensity actually, and second topic will be phase difference, and third topic will be wave properties. Wave properties like reflection, refraction, and diffraction. Okay, so let's get start with wave intensity, and it is represented by symbol I. Okay, so what is meant by wave intensity? Intensity means actually the strength or the number of waves. So we can say that we can define it in two ways. The first way is energy transferred by a wave per unit area per unit time. And for this, we can write the equation as intensity equals energy over area into time. So this is our main equation, and in symbols we can write it as I equals energy over area into time. If you talk about its unit will be joule per meter square per second. So this will be the unit of intensity. Talking about the second definition of intensity, you can also define it as power transferred by a wave per unit area. And about equation, intensity can be power over area. So in symbols, you can write it as power over area. Why it is like that? Because if you look in the upper expression like this, energy over time is actually power. So that's why you can write it as intensity as power over area, and of course its unit would be watt per meter square. Let's discuss the factors of intensity now. Intensity is really important term in waves. So it is having three main factors. Factor number one is known as amplitude. So amplitude of wave changes the wave intensity with a relation like this: intensity directly proportional to amplitude square. Or in symbol, you can write it like this, or even you can assign a constant k with it as well. So it means that if you are increasing amplitude by 2 times, then the wave intensity will be increasing 4 times. Or if you increase amplitude by 3 times, then the wave intensity will be increasing by 9 times. On the similar scale, if you decrease the amplitude by 4 times, the intensity is going to be decreased by 16 times. Okay, the second factor is frequency of the wave. Okay, this factor is also similar to the amplitude, like intensity is directly proportional to square of frequency. So if you assign a constant is k, so I equal k f square. Its meaning is also the same, that if you increase frequency of waves 2 times, the intensity will be increased 4 times. Or on the other hand, if you decrease frequency 3 times, the intensity would be decreased by 9 times. Okay, uh, so we have done with 2 factors. So the third factor is distance covered by wave. So about distance covered by wave, this intensity is represented by inverse square law. This is also known as inverse square law. Okay, in factor form, it can be I equal k over d square. So k is the constant. Okay, what is d over here? D is actually distance moved by wave. Distance moved by a wave. So if a wave covered greater distance from its source, then its intensity keeps on decreasing. Let me tell you this with an example. Let's say this is the source which is generating a wave, and let's say this wave is going to this path. Okay, if the wave just reaches this point, this is point P, so this point is at a distance of x, and its intensity is I at this point, right? And then if it further moved to another point Q that is at a distance of 2x from source, then what would happen? The intensity, as the distance is increased 2 times, so according to the relation, the intensity is going to be decreased by 4 times. So it means the new intensity at this point would be I by 4. And if the wave has further covered a distance till point S, and that is at a distance of, let's say, 3x from this source, then at point S, as distance is 3 times to that of distance at P, so its intensity would be decreasing 9 times to the intensity at P. So the new intensity at S would be I by 9. So that's how wave intensity changes or decreases, in fact, with the distance. So this happens with all the waves. As sun is emitting the waves, so those waves are reaching earth. So as the rays are light rays or heat rays are covering distance, so their intensity or their energy keeps on decreasing. Okay, so now we have to do an example. You have to look very carefully to this example, because after this you are supposed to do some question at your own by pausing the video. Okay, so look at the example. The example is, let's say, first example is a statement type question. Okay, so what's the statement? The statement is a wave is having intensity I with amplitude 10 millimeter. A new wave have twice the intensity to that of first wave. So the question is, what will be its amplitude. Okay, so how you will do that? First of all, you will observe that in this question, intensity and amplitude are given. So you will say, okay, I have to use this relation actually. I proportional to amplitude square, or you can simply uh, write A for amplitude. So I proportional to A square. Then you will collect the data. The data is for first wave, the intensity is I, and you can use a ratio sign at this proportionality sign. So what's the amplitude? 10. So make sure to take it square because it's amplitude square over there. Okay, now what you have to do, you have to do this for second wave. Okay, for second wave, the intensity is twice, so it is 2i, and you need to find amplitude. So you can write unknown thing as x, but you have to take square because in the main relation it is a square. So now as these two are directly proportional to each other, so whenever two things are directly proportional to each other, you can cross multiply them. So for direct proportionality, cross multiply. Okay, and in case the things are inversely proportional, then you need to make a ratio and then you will be linearly multiplying them. Okay, if you now let's solve it. So it would be x square into I equal 2i into 10 square. So your I will be cancelled away. So it would be x square equal 10 square is 100, 100 twos are 200, taking square root on both sides. So your x will be 14.14 millimeters. So this would be the new amplitude. I hope you'll get this. Okay, let's go to next example now. Example 2. Example 2 is wave drawing. You need to draw a wave now. Okay, if you need to draw a wave, let me sketch the wave for you. Okay, along x-axis is, let's say, distance, and along y-axis is displacement in millimeter. Okay, negative y-axis is also displacement in millimeter. Okay, now you have the first wave, and you have the first wave as this. So this is your first wave, P. Okay, so the amplitude is shown over there, which is like, let's say, uh, it is 2 millimeter, -2, -4. Okay, now what you have to do is, it's actually the exact same question as the previous one, the statement one, but this is in the form of a wave drawing. So the question says that you have to draw second wave of same wavelength but 3 times the wave intensity as that of P. Okay, so it means you have to do the same thing, but this time you need to draw it. Okay, so let's solve it. Again, you'll say that, okay, intensity and amplitude are given, so you'll be using this relation again. And for the first wave that is over there, let's assume that its intensity is I. As intensity is not given, so you can assume it as I. If intensity of any wave is not given, then you have to assume that, okay, let's assume its intensity is I, and then its amplitude is in the diagram, which is 2. If you look upon the diagram over here, its amplitude is 2. Okay, then for the second wave, you have to write down the data as its intensity is 3 times So it's 3I, and you require to find its amplitude. Again, what you will be doing is cross multiplying them. Okay, so let me solve it for you now. X squared into I equals 3I into 2 square. So I would be cancelled away with I, so you'll be left with x squared equal 2 2s are 4, 4 3s are 12. So now what you have to do is you have to take square root of this 12. So let me take square root of 12 quickly for you, and that is 3.46. So x is 3.46 millimeter. So now you have to draw a wave of same wavelength but amplitude of 3.46 millimeter on diagram. So let me draw it for you over there on the diagram. Okay, so first I have to identify where is this 3.46. So 2 and 4 in the middle, this is 3, and somewhere over there it should be 3.46. So I'm just drawing a dotted line just to make sure that I would not be crossing from there. So now I have to smoothly draw a wave by keeping its wavelength same, and like this. So this is my new wave. So I'm done with that. I hope you will understand that. If not, you can go back, you can listen it again. Okay, so in the same way, you can practice for the other questions. So same method to be used for other factors. And what are the other factors? Actually, I already told you. Once again, I'm telling you this: intensity proportional to frequency square, and intensity is inversely proportional to distance covered by wave. So in case if you encounter a question from this, from frequency or distance moved, then you have to use the same procedure I have used in first two examples to sort out the new displacement. Okay, so we are good with intensity now. So let's move on to the next thing, which is phase difference now. So the new topic is phase difference. Okay, phase difference symbol is delta phi. Okay, before we study phase difference, what is meant by phase? Phase is actually the state of a vibrating particle. If you just look upon what is phase, phase is state of vibrating particle. And in order to determine the state of vibrating particle, we look upon three things. First thing is displacement of particle, second thing is speed of particle, and third thing is direction of particle. So if a particle, if any two particles are having all these three things similar, then we say that uh, those particles are in phase particle. So what are in phase particles? In phase particles are the one which are having same speed, direction of motion, and displacement. So usually the in phase particles are lambda apart. So lambda or multiple of lambda apart particles are said to be in phase. Okay, and same is for the opposite actually is for out of phase particle. Out of phase, the name is suggesting that okay, they are not similar to each other. So particles with different speed, displacement, or direction of motion are said to be out of phase particles. Okay, now let's go to phase difference, our main topic. Its symbol is delta phi. Okay, phase difference, first of all, we have to look upon at its definition. So the phase difference between two vibrating particles, the phase difference between two vibrating particles is the of a cycle. Fraction of a cycle means fraction of lambda, or it can be an angle between the two vibrating particles. So this is how we define phase difference. It is actually the fraction of a cycle between two vibrating particles, or it can be fraction of cycle between two waves. So it can be fraction of cycle between two waves. Okay, we measure it in the unit of radian. So its unit is radian because we are going to measure it in the form of angle. So radian is the SI unit, while on the other hand, degree is non-SI unit. So in one cycle, there is 2 pi radian or 360 degree. This is the main relation. Okay, if we look upon the waveform, let me draw a waveform for you. Okay, so here we go. This is one waveform. So if let's say along x-axis is time, so if I draw different points, like this is my first point, this is second point, this is third point, fourth point, and fifth point. So if you look upon these points, initially when there was no wave, all these points were at the mean position. But now, as the wave has, one complete wave has passed through it, then uh, the displacement of each of the particle has been changed. So they are in different phase now. All the particles are in different phase, right? Even the particle 1, 3, and 5, they have gone through some oscillation to reach their mean position again. Okay, so straight away, I can give you one example that you can treat your wave like if the wave is like this is crest, this is trough. So what you can do is, if this is crest, just fix your trough below it. So it's almost equivalent to a complete circle. So in one circle, the angle is 360 degree or 2 pi radian. While in half circle, the angle is 360. So the half circle is actually a simple crest or a trough. So angle for one crest is how much? 180 degree or pi radian. And then for if you add another 180, so the total angle for one wave will be 360 degree or 2 pi radian. While if you cut short one crest, then half of the crest will be 90 degree or pi by 2 radian. And the 3/4, if you look upon 3/4 of the wave, it would be 270 degree, or it would be um, 3 pi by 2. So this is the angle associated with one wave. In fact, we can associate uh, other things to wave as well. For example, this is one wave. So if I need to point out the values, then what are the possible values that can be over there? If it is distance, for one wave it is lambda, for half wave, uh, for half of the wave it is lambda by 2, and for quarter of the wave lambda by 4, and this is 3/4. Okay, if you can also do it for time, like for one complete wave the time period is t, for half wave it is t by 2, for quarter it is t by 4, and for 3/4 it is 3t by 4. Okay, you can also do it for angle in radian. So one wave is 2 pi, half is pi, and then half of like the quarter of the wave is pi by 2, and this is 3 pi by 2. And you can also write this angle as 360 degree, this is 180 degree, this is 90 degree, and this is 270 degree. So these are the values. I hope you will understand this. Okay, so now how to find phase difference? How to find phase difference? So to find the phase difference, what you have to do is you have to there can be two situations actually. Situation one is the phase difference between two particles in one wave. This can be first situation, and second situation can be between two waves in same medium. So you can also find phase difference between two waves. So for both of these situations, we'll opt the same method. So same method for both the waves, both the method actually. Never mind, it's actually same method for both the cases. Okay, so what's the equation to find phase difference? The equation to find phase difference is delta phi is 2 pi x over lambda, x over lambda. And you'll be using this equation if along x-axis is distance, like if a waveform is there and along x-axis is distance, and you need to find phase difference between two particles or between two waves, then you will be using this formula. On the other hand, this formula can be transformed into another formula with different terms like this, and you will be using this if along x-axis is time. So if along x-axis is time, you simply have to replace x with small t and lambda with t. Okay, you have to be careful with this thing, as what is x in the above equation? X is actually separation between two particles or two waves between which you need to find the phase difference, and x in units of length. X can be in unit of length, or x can be in fraction of wavelength. So it can be in fraction of lambda. If x-axis is not marked with the values, then you have to give value of x in terms of fraction of lambda, like lambda by 2, lambda by 4, lambda by 3, like that. I'll give you an example after this. Okay, so we're done with x. So what is lambda over there? Lambda is actually the wavelength of wave given. Okay, and in the similar way, if you look upon t, small t, so small t is again the same thing. It's the separation between two particles or two waves, and capital T is time period of that wave. So you can use that to find the phase difference between two vibrating particles. Okay, let me take you to the next page. Okay, and let me show you an example. Okay, the example is like you need to find phase difference between two vibrating particles. Let's say first I choose distance along x-axis, and this is your wave, and on the wave these are your particles. So these are the particles. Let me label them as 1, 2, 3, 4, 5, 6, and 7. Okay, now what you have to do is you have to answer some question. So the question is, find phase difference between followings. Okay, so the first one is you have to find phase difference between 2 and 4, 2 and 4 particles. So how you will do that? So first you will say, okay, what is the distance? What is the x-axis? It's distance. So you'll say, okay, let me use the formula. Delta phi is 2 pi x over lambda. Okay, done. Then you will say, okay, 2 pi, and then you have to look for x. What is x? X is actually separation between 2 and 4. So x is separation between particle 2 and particle 4. So separation, if you look upon x-axis, this particle 2 is over here at the middle of the crest, and particle 4 is at the middle of the trough. And one more thing is that you need to find actually this x. But now, as distance axis is not labeled with the values, so what you will be doing, you will be using fraction of wavelength now. So what is distance between crest and trough in terms of lambda? In terms of lambda. So guess your answer. Tell me your answer. What can be the answer? What is the distance between crest and trough in terms of lambda? Loudly. I'm not hearing your voice. Yes, you're right. Actually, this x is equivalent to lambda by 2. So what you have to do is you have to put value of x as lambda by 2 over there. And now you have to look upon lambda, right? This lambda, this. So if you look for the lambda, you know that length of one crest and one trough. But again, as distance axes are not labeled, so what you will do is you will say that this lambda is actually lambda. The wavelength of this wave is lambda. So now next, these would be cancelled away, 2 with 2 and lambda with lambda. So you are left with phase difference of pi radian. So you will say the phase difference between particle 2 and 4 is pi radian. Now it's your turn. You need to look upon the question, and then you need to pause the video to do this question. And then you will look upon the answer, which I will provide at the after this. Okay, so the question for you is, find phase difference between particle 3 and particle 6. Okay, so pause the video now and solve the question, and as soon as you solved it, again play the video to uh, check your answer. So you have to pause the video right now. Pause the video and solve it. Okay, okay. Hopefully, you must be done with the question. So let me solve it for you. As the question was this, that there was a wave with the particles 1, 2, 3, 4, 5, 6, and 7, and you were required to find the phase difference between particle 3 and 6. So particle 3 is over here and 6 is over there. So first you've seen that the distance along x-axis is distance, so you would be using this expression, and then 2 pi, and then place of x. What is x? X is the distance between 3 and 6. So the distance between 3 and 6 is this x. So you have to tell this distance in terms of lambda. So in terms of lambda, it is like 1, 2, 3. So this is 3/4 actually. So 3 lambda by 4, and then lambda is lambda. So you have to solve it. Lambda will be cancelled away. 2 2's are, so the delta phi would be 3 pi by 2 radian. So this is the phase difference between particles 3 and 6. If your answer is correct, that's good, you got the concept. If it is incorrect, you have to look from where you have done wrong. Okay, so so now let's go to waves, phase difference. We have to find phase difference between two waves now. Okay, so let me draw an example for you. Let me take this time along x-axis. So I'm going to draw first wave as this. So this is your first wave A. Okay, now along x-axis, what I can do is I can label the time values for you. Let's say this is 2 millisecond, 4, 6, 8, 10, 12, and 14 millisecond. This is 0, by the way, and along y-axis is always the displacement. Okay, so what you have to do, what is your task? You have to um, draw a wave of phase difference 90° or pi by 2 radian as compared to wave A. So there is another term, phase lag, phase lead. I'll tell you this in a next lecture, but over here we are simply looking at how to draw another wave which is having some phase difference. And one more thing which is given, that both waves have same time period and intensity. So it means that you have to take their time period along x-axis and along y-axis amplitude. The amplitude would be same. Okay, so what we have to do, we have to first see that as along time axis, the along x-axis the value is time, so the formula would be 2 pi small t over capital T. So as it is given that phase difference is pi by 2, so just writing these values, 2 pi is this, and we have to find t. We have to work for actually small t. And what is the time period? You'll go back and look over there. What is the time period of this wave? It is 8, right? So it means that you'll be writing 8 over there. Now you have to do some simplification. So pi is going to be cancelled out with pi, and then this 2 cancel with 8, and then 2 2's are, and from here you can write that this 2 is actually time is actually 2 milliseconds. So this time, what is this t? This is actually separation between two waves. It means that if we go back, we got a time of 2 milliseconds. If we go back, we have to start second wave from 2. Okay, second wave from 2, and we have to keep the time period and the intensity same. Okay, it means I have to draw it to the same level, and I need to keep the time period same. So for first wave, time period is 8, and half of the time period, our time period for crest is 4 seconds. So what I will do is I will draw the first crest like this, and then for trough like this, and then again for crest it would be like this, and from here you can extend it like this. So this is your new wave. So if you look upon the separation between the identical parts, it's like if you look upon this crest, red crest, and the black crest, actually red crest is at 2, black crest is at 4, so 4 minus 2 is 2. So that was what we figured out over here. So I hope this thing will be cleared to all of you. Now, a question for you. You have to look at it, then you have to pause the video, and you have to solve it and again play the video to look for the solution. Okay, so long x-axis is distance. Let me draw first wave for you from here. Okay, this is first wave, and let's say I'm going to mark the distance as 2, 4, 6, 8, 10, 12, and 14. Okay, what you have to do is now you have to look for a second wave, or you have to draw it actually. Draw a second wave of twice intensity to wave P. Let's say this wave is P, and along y-axis is displacement, that is in millimeter. So right now the displacement shown is, let's say, 2 and minus 2. So draw a second wave of twice intensity to wave P, and with a phase difference of, okay, the phase difference of 60 degree r pi by 3 radian. So you have to draw a second wave. Now what you have to do is pause the video and solve the question. Solve the question on your copy, and you are having exactly 5 minutes to do that. If you are done before 5 minutes, it's good thing. Okay, so let me tell you its solution now. So there are two things in it. The first thing is amplitude of new wave. You have to look for amplitude of new wave, right? So you'll be using this expression. So for the first wave, as it is given, as intensity is not given, so you can assume its intensity as I and amplitude was 2. Okay, for second wave, the intensity is twice, as it was mentioned over there, uh, twice the intensity. Okay, so it is 2I, and you need to find its amplitude actually. So again, you are cross multiplying it to get to your answer. like this. I'll cancel away, and x square is 6. And what you have to do is you have to take square root of 6. So square root of 6 is 2.45, right? It's 2.45. It means that now you got the amplitude of 2.45. Okay, so phase difference is 60. So second is you have to find for x through phase difference, through phase difference. Okay, so what we'll do is as along x-axis there is distance, so we'll be using this formula x equal, sorry, it's actually delta phi equal 2 pi x over lambda. So what's the phase difference? 60 degree, or it is pi by 3 in radians. So 2 pi, and x, you need to figure out how much is x. And then for lambda, if you go back, lambda is 8. Yeah, lambda is 8. So at place of lambda, you're writing 8. And now you have to cancel out these things to get value of x. So x is 4 by 3. So 4 by 3 is actually 1.33 centimeter, 1.3 centimeter. Okay, now new wave drawn. Okay, let's draw the new wave. I'm not taking you back to previous page. What I'm doing is I'm going to redraw the wave over here, I guess. One more, like this, and it was 14. Okay, so 2, 4, 6, 8, 10, 12, and 14. Again, amplitude was +2, -2, and along here is displacement in millimeter. So the displacement is 2.45. So what we'll do is 2.45. Okay, like this is 1, this is 2, this is 3. So 2.45 is falling somewhere here. So 2.45, and then like if 3 is there, so 2.45 will be over there. You need to keep amplitude till there, and then x is 1.33. So if this is 2, this is 1, so 1.33 should be somewhere here, 1.33. So what you have to do is you have to start your wave from here, from 1.33. Okay, now okay, so 1.33. Another thing can be that as this x is the distance between your identical points. So you can say that if this is the crest, so the crest of your wave should be at a distance of 1.33 from this. So 1.33 is coming over here. So what you can do is you can start drawing the crest from this, and then if you look upon this distance of one crest, it is 10 minus 6 is 4. So length of one crest is 4 centimeter. Okay, so half of the crest will be 2 centimeter then. So if the crest is starting from 1.33, it should be ending at 3.33 centimeter. So you have to locate where is 3 point, there is 3, and 3.33 is right over there. So what you have to do is you have to make the crest. Okay, so what you're going to do is just make the crest like this. It's a bit not very smooth, but it's fine. Okay, from 3.33 you have to add a trough. So what's the length of the trough? It's 4 as well. So 3.33 plus 4 gives you 7.33. So look for the point 7.337, and 7.33 is over here. So that will be the length of one crest. By the way, we missed one thing. We have to start it from from here, right? So let me redraw it like this, and then like this, and then you have to draw another crest. So 7.33 plus 4, that would be 11.33. So where is 11.33? This is 11, so 11.33 is over here. This is the point of 11.33. So what you'll be doing is making it like this. So this is your new wave, and you can draw it like this. So this is your new wave. I hope this thing is a bit challenging. You can relocate, and you can try it again. So thank you very much, students. Take care of yourself. Inshallah, tomorrow I'll see you in the live session. So in case of any problem, you can post your queries in the chat box, and I will try to answer them as soon as possible.